separate objects. I could measure the angle between a beach ball and a house. Now, when I point the sextant at a beach ball, the edge of the beach ball isn't a flat baseline, but I can still measure that angle.
The horizon is horizontal, ladies and gentlemen, not curving at all. There's your horizontal baseline.
Right, but
You don't get it from a curve.
The horizon is also always below eye level, which is why we add dip correction to our measurements.
But it's still horizontally flat and level, ladies and gentlemen. That's the thing. It's a horizontal baseline. Please keep focused on that.
And you're not speaking from experience.
Stop embarrassing. Jen.
Telling you, stop embarrassing the flat earthers, man. Yeah, you are graduated from Nathan Oakley University.
I'm always going to keep on talking. I'm always going to keep on talking, and please don't keep calling my name and saying you're the one that's embarrassing the flat earthers. You're a walking embarrassment and contradiction is what you are. Okay,
you're graduated from.
I'm nearly finished. You claim. Look, I'm trying to finish. You claim to call yourself a flat earther, but you argue the globe points all the time. So please don't call me. I've been around for 10 years. I'm not going to change, and you're not the standard I'm going to be following. Okay, thank you.
You don't even understand what horizontal line is. Could you please define me what horizontal line is?
Yeah, I don't need to do that. I don't need to do that at all. If you don't know what a horizontal line is.
You're just a little child graduated from Nathan Oakley University.
This is how it gets silly, because now you're attacking Jin CBR1. I will destroy you. I don't want to make that noise on this server. Basically, if you don't know what a horizontal line is, go and research and investigate that. I don't have to tell you that. You don't know what it is. That's your problem.
Yeah, New Moon, you didn't have to attack him like that. With personal attack.
I'm not doing that. I'm asking him what's the horizontal line is. He's saying, look for yourself. I'm saying the horizontal line is, okay, I'm going to tell you. The horizontal line is, you have your plumb line. Whether the earth is flat or globe doesn't matter. There will be a plumb line that's called the vertical. So your horizontal line is orthogonal to the vertical. It's 90 degree to the vertical, perpendicular to the vertical, and it is not parallel to the shape or the surface of the earth. Your horizontal line is just a mathematical line. And
I'm sorry, go ahead. I thought you were done.
Wherever your horizontal line meets the horizon, it's called the celestial horizon. It's not the apparent horizon. It's the celestial astronomical horizon. And that means on the celestial sphere, the point where horizontal line meets, it's called the celestial astronomical horizon. And that's why there's
a bubble sextant, like what's used in airplanes, actually measures the angle to the stars relative to that vertical using a bubble level, because a bubble level basically measures a plumb line and then it's horizontal to that. So for people using bubble sextants, they actually don't need to do any dip correction because they're actually already measuring perfectly horizontal to begin with. It's just that nautical sextants need dip correction because you're always measuring from a little bit below horizontal.
Thank you very much for that. That's excellently eloquently put. And ladies and gentlemen, before you can get a plumb line, you have to first have a horizontal baseline. If a bricklayer is going to make a brick wall, okay, he can't make the brick wall until he has a proper horizontal baseline, and then he can start to do the plumb from there. Okay, you can't just put a plumb in the middle of the air, just at the click of a finger, and now you've got your plumb in space. That's an absurdity beyond belief.
Are you lying?
So
why you can't put a plumb line without a horizontal line? Can you tell me?
And if I could ask, when you're using a nautical sextant, you're pointing it between your eye and the horizon, but the horizon you see is always below eye level. So if you're measuring from your eye to something below your eye, how could be considered a horizontal baseline?
Yeah, and horizon is changing. Horizon it's not even physics. It's apparent. So if you are basing your angles of the stars based on horizon, then it will change. You will not get measurements of the stars because the horizon is going up and down with reflection.
And that is true. Celestial navigation with a sextant isn't a perfect science, and there is always a little bit of error.
No, you can't do that because in astronomy, the zenith angle, if you add your zenith angle with the elevation angle, then it should be 90 degrees. If it's not, then you can't do that. Your data is incorrect, because your data should be zenith angle of a star, and the elevation angle of that star should be always 90 degrees, addition of both. But if you're using sextant, then you
Yeah,
can't do that,
90.
Well,
because
when
your apparent horizon is not 90 degrees to your zenith. You need to understand that, man.
yeah,
These are
that's
simple
why we
things.
add dip correction. So if the actual altitude, the real altitude is like 20 degrees of a star, a sextant is going to measure it at 20 degrees plus a couple of arc minutes. Then we
He's
subtract dip correction. That dip correction is what will bring us back to exactly 20 degrees.
do you know what's the funny part is? He thinks like the horizontal line is the surface of the earth. Oh man, the horizontal line is flat line. The surface of the earth is have topography. It's not flat surface on the flat earth also. He thinks like on the flat earth there's no mountains and valleys. It's completely flat like a line. That's so funny. Like
The
Nathan
reason we use
O'Connor.
the reason we use the ocean, ladies and gentlemen, is because it's an uninterrupted expanse, uninterrupted. If you use where the mountains and the valleys are, then you have to account for that. But the point we're making out here and telling you is that the circumference of the 24,901 mile radius, circumference, the radius of it is 3959. We're not able to measure that radius. And that's why we say flat earth. We know that there's mountains and valleys and hills and ponds and lakes and ocean, okay? But that's why we take the ocean more. I'm nearly finished. That's why we use the ocean more, because it's an uninterrupted expanse of area. And that's why we prefer that.
There's no
Thank you.
waves.
And
And
it's
if
level.
you think, and if you
And
think
I'm nearly
any
finished.
flat earther,
Are
and
you
if you
claiming there
think
are no
any
waves?
flat earther thinks that the earth is flat, you're touched in the head. We know that there's bumps, hills, valleys. So if you think that Jin thinks that the earth is flat, you're touched in the head. That's all I have to say.
Can I
He's
ask Jin if
just a second. Just a second. He thinks there is no waves in the ocean. He's saying there is no interruptions in the ocean. That's why he's using horizontal line parallel to the
that's a
ocean
straw
surface.
man?
He's saying there is no waves in the ocean, right? Because
No, he never said that. Even as a glober, I'm not gonna let you straw man Jin.
you ask him in his horizontal line, where is the waves? Because he thinks the horizontal baseline is the surface of the earth, is the surface of the water. So horizontal baseline doesn't have any kind of waves. So how can there will be waves
I
in the real?
think Jin might be confusing like the horizontal, like all around you line of the horizon with the line of sight from the sextant to the horizon. So a sextant doesn't measure across the horizon. It measures from your eye to the where the water meets the sky, across, away from you.
Yeah, that's the horizon, exactly. I'm not confused at all. No chance. And the reason I use the word uninterrupted expanse, we don't have mountains and valleys and hills and lakes and ponds interrupting our line of sight, you see. That's it. It's clear English. And remember, to get that 90 degree, you're going to need a horizontal baseline to get your perfect 90 degree. That's what we're saying, ladies and gentlemen. It's clean, it's clear, simple.
That's genetic, man.
I mean, I guess I can generally agree that between flat and globe, we can agree that a sextant can measure the angles to stars. There's definitely common ground there. The real kicker is when we try to actually plot the measurements on the surface to find our location. Getting the sites is only step one. Step two is actually finding your location, which must involve a sphere. One. Step two is actually finding your location, which must involve a sphere. Getting the sites is only step one. Step two is actually finding your location, which must involve a sphere. Getting the sites is only step one. Step two is actually finding your location, which must involve a sphere. Is when we try to actually plot the measurements on the surface to find our location. Getting the sites is only step one. Step two is actually finding your location, which must involve a sphere.